Hello and good morning, dear students. So today is 7th of August and so far we have completed almost all the sums from this chapter and exercise, and now we are at the end of this. Okay, so today we'll complete this exercise as well. So now the question I am taking today is question number 23. The question says prove that 0 to pi by 2 log sin x dx is equals to 0 to pi by 2 log cos x dx. We have to prove from here to here, and then finally from here to here we have to prove. Okay, so from here to here is a very easy thing. See, it is 0 to pi by 2 log sin x, so I can use property number 4. By the I want to keep this as I, so let I equals to this. Now use property for wherever it is x, it will be upper limit minus x, so sin 90 minus x is cos x. So this is equation number 2, hence we have proved from here to here, isn't it? So pause the video, note it down till here. The first part is done. Alright, I hope you are clear from here till here. Now, as same as we have done before, taking this equation number 1 and taking this equation number 2, we can add equation 1 and 2. And after adding, what will I get is very simple. I plus I will be 2i, and this dx, this and dx is common. So inside the bracket, I'll be getting log sin x plus log cos x, which is this. It is in the form of log a plus log b, so which will give you log a into b. Alright, now log sin x into cos x, if I keep it as log sin x into cos x, then I will not be able to proceed. So hence I have to do something out there, and that something is I am multiplying 2 in the numerator and dividing by 2 in the denominator, because if you cancel 2 and 2, again you get back sin x into cos x. But if I multiply with 2 and divide with 2, then I will be getting log, the formula for 2 sin x cos x is sin 2x. 2 sin x cos x is sin 2x divided by 2. So I hope you are clear till here. Please pause the video and note it down. Okay, so after this step, then it is in the form of log a by b, which is log a minus log b. So log a minus log b, and also open the integral with this. So this integral is very easy to evaluate. In fact, this integral will only give you the answer as this. If log 2 is a constant, so we'll be getting pi by 2 into log 2. Actually, this is the answer, but what happens to this integral is very important now. What happens to this integral is very important. By the way, this was our capital I, isn't it? Okay, what happens to this integral is very important. Now we will be solving this integral. Okay, so let us keep this equation as in this way. 2i, I want to keep this whole integral as I1, because now we'll simplify the value for I1, right? I1 minus log 2 is a constant. You can integrate out here. It will be pi by 2 minus 0. So therefore 2i is equals to I1 minus, this will be pi by 2 into log 2, and I will keep it as equation number 3. Okay, I will keep it as equation number 3. Now please focus out here. It is 2i is equals to I1 minus pi by 2 into log 2. But I should be proving I is equals to. I should be proving I is equals to minus pi by 2 into log 2. I should be proving I is equals to minus pi by 2 into log 2. I am getting 2i is equals to I1 minus pi by 2 into log 2. So the catch is out here. If I can prove that I1 is equals to I, if I can prove I1 is equals to I, for example, out here I'm writing, if I can prove, after simplification, if I can prove I1, this I1, that is this I1 is equals to I, bring this side, it will be I, 2i minus I is I, which is equals to minus pi by 2. So that is going to be our job out here. We will try and prove this I1 is equals to I. Okay? By the way, how I'm getting I1? I1 I'm getting by substituting, isn't it? So here you can write down, here your I1 is equals to 0 to pi by 2 log sin 2x dx. So I hope you're clear till here. Now we'll simplify this. Please pause the video, note it down. Alright, dear students, so let us continue from here. This is our I1, isn't it? So this is our I1, which means this whole integral, I'm taking it as I1. Now my job is to prove I1 equals to I. I told you before also. Let us solve. Okay, I1 equals to this. The first step we are doing is the substitution out here. You substitute 2x equals to any variable. I'm taking p. you'll get the value for dx as dp by 2. Now since there is limits, so when x equals to 0, p equals to 0, and when x equals to pi by 2, p equals to pi, which means this line. I hope you're clear with this. So after putting everything, I1 becomes 0 to pi log sine p and dp by 2. Now this half comes outside, so I'm getting 0 to pi log sine p dp. Now what I'm going to do out here is I'm changing the variable from p to x by using property 0. Remember property 0? The first property we have is called p0. We can change from variable p to t, p to x, isn't it? So I'm changing from p to x. Everything is same. Half, 0 to pi, log, sine, p changes to x by property number 0, p0. Okay? So please pause the video, note it down till here. Alright, so I hope till here you are done. Now come back out here. I1 equals to this, the same thing. Now, I have told you before through property number 6. Property number 6. What was your property 6? Property 6 was 0 to 2a fx dx is equals to twice 0 to a fx dx. Another one was 0. The conditions you know, I hope you know the conditions. The first one I can use if f of 2a minus x equals to f of x. Second one will be 0 if f of 2a minus x is minus fx, isn't it? Now the same property we're going to use out here. That's why this question is very, very important. It's very lengthy, also important at the same time. So many properties we're using out here. We use property 4, we use substitution, and then I use property 0, and now I'm going to use property number 6. Then only I'll be getting the value for I1. Okay? It's not so difficult also. Now see, how can I make changes out here? I1 equals to half. This pi I can write as twice of pi by 2. 2 gets cancelled out. I'll be getting pi. Log sine x remains log sine x dx. Alright. Now, from property 6, if I have to use, so it is in the form of this integral, if you see 0 to 2a, keeping pi by 2 as a. Keeping pi by 2 as a. 0 to 2a, it is in the form of property 6, isn't it? So what does property 6 tells? Assume this as fx. Assume this as fx, this is your fx. Now you find upper limit minus x, f of 2a minus x. So f of 2a, f2a minus x. So wherever it is x, sine 2a minus x, 2 gone, it is pi minus x. Now sine 180 minus x, you have to know the formula, make the quadrant. Sine 180 minus x, all sine, tan, cos, this is 180. 180 minus x, so lies in the second quadrant. Second quadrant is sine is positive. Even multiple sine remains as sine. Okay, so sine 180 minus x will be sine x. So log sine x means fx, isn't it? So I am getting f2a minus x is equals to fx. So therefore by property number 6, from here, so by property 6, what can I write is I1 is equals to, it was half, right? Half is already there. Now the value for this will be twice 0 to pi by 2. Okay, see, I'm writing the value for this. Half was already there, half is already here. Now this, it satisfies property 6 property, isn't it? This integral satisfies property 6 property, so hence the value for this integral will be no more 0 to 2 pi, but it will be twice 0 to a, that is pi by 2, and log sine x dx. Clear? So therefore I1 will be 2 gone, so 0 to pi by 2 log sine x dx. Now what is the value for 0 to pi by 2 log sine x dx? It is I. So hence I got I1 is equals to I. Now my job is done. So now what we'll do, we'll go back to equation number 3. So please pause the video and note it down till here. Alright, so when you check your equation number 3, the equation number 3 was this. Sorry, not this 3. Equation number 3, I have written this one, right? So from equation number 3, we have 2i equals to I1 minus pi by 2. You got the value for I1. Please put the value for I1, which is I. Bring this side, 2i minus I will be I. Hence the value for I will be minus pi by 2 log 2, which is this. So this is equals to this, and then finally combination of this is equals to this. Okay, very, very important question for your IC. If it comes, it will come from 4 to 6 marks. So please pause the video and note it down. Alright, so this is with the last sum. And last sum of the exercise, the half of the sum I've done out here, and rest you'll complete yourself and you'll take it as your assignment. Okay. The question is I is equals to 0 to pi x log sin x dx. So straight away use property 4 out here. It will be pi minus x, and in place of x will be pi minus x. By the way, sin 180 minus x is sin x, and pi minus x, keep it as pi minus x, multiply with log sin x, and this portion, if you see, it is your I. So bring this side, I plus I will be 2i. 2i is equals to pi into 0 to pi by 2 log sin x dx. Keep it equation number 1. Again use property 4 in this integral. If you use property 4 in this integral, 2i is equals to pi. 0 to pi, everything will be same, just sign changes to cos, because sin 90 minus x is cos x. Okay, so adding equation 1 and equation number 2, then you will be getting this, and now you know what to do. It is same as question number 23. Please solve it. Okay, make the assumption, change the limits, and then finally you'll get the value for I. So that's it for today. Complete this assignment and submit it by tomorrow. And in the next class, we'll be starting differential equation. Okay? So thank you.